In this video, we are going to see force between charges on a partial dielectric medium or a dielectric slab is present. Consider two charges, Q1 and Q2. Both of them are separated by a distance r. A dielectric medium whose thickness is T and a dielectric constant K is introduced between these two. So you call this distance as x and this distance as y. So from the diagram we have x plus y plus t is equal to d, x plus y is equal to d minus t. So what is the effective distance that will be felt by the charges in air or vacuum? So effective distance d air is equal to, so what is the distance in air here? X and y, so x plus y into, when a medium is present, the distance felt by the charges in air will be root k times t. As we have seen in the previous derivation, r naught is equal to root k into r. R is the distance between the charges in medium, r naught is the distance felt by the charges in air or vacuum. So by using that, here we can write root k into t. But from here, x plus y is equal to d minus t, substitute here, plus root kt. Now take t common, so d plus, if I take t common, root k minus 1. So the effective distance felt by the charges in air is d plus t into root of k minus 1. So what is the force experienced by the charges? Now these two charges will feel how much of distance now? D plus t into root k minus 1, and this is the distance that will be felt by the charges. So the force between the charges will be equal to 1 by 4 pi epsilon naught q1 q2 divided by d plus t into root k minus 1 whole square. And this is one of the very useful expression in finding out force between charges when a medium is present between them. Now, if the entire gap is filled with the charges, that means the thickness of the medium is equal to d. If t is equal to d, substitute here. Here, t into root k minus t, d, and minus t d, both of them will get cancelled, and we are left with t into root k whole square. Root k whole square is k into, instead of t, I can write d here, d square. So I can write this one as F is equal to F naught by K. What is F naught? Force between two charges when only air or vacuum is present. That means when two charges are present, entire gap is filled with the dielectric, then the force between the two charges F is equal to 1 by 4 pi K epsilon naught into Q1 Q2 divided by d square. But if I write K separately, I can write this one as F naught by K.